Wow, beautiful.
Today you will learn by just me going through the Delta math problem sections, and you're going to just ask lots of questions. I don't think at any point is it super hard. But today you're going to learn about um, some four new words: increasing, decreasing, positive, and negative. And you know all those words like from English, like what they mean. What does it mean to you when something increases?
It goes up.
It goes up. We can say the same thing about a graph. If a graph's going uphill, it's increasing. What does it mean to decrease?
It's going down.
It's going down. What does it mean to be positive?
It's above zero.
You're above zero. To be positive means you're above zero. And we're going to come to know zero as the x-axis. Zero is like that line in mathematics that separates positive function values from negative function values. And so the word positive means above the x-axis, and the word negative then, of course, means below. So let's get started with this. And again, it's hard to take notes today. I get that. I wouldn't even expect it of you. The mission for me is when you walk out this door today that you're going to be like, okay, tomorrow when we work on this, I feel like I can do this by myself. That's the goal. So here we have a graph, and I'm just going to keep clicking through until I find what I hope is an example of everything that you're going to be asked to do. It says to determine the domain. Remember, the domain is x values over which the function is increasing. So we just talked about this. What does it mean to increase? It means to go up. And so I may have to zoom out just a tad here. So for this function to be increasing, you would agree that you would have to be anywhere from here to here. Anyone have any complaints on that? So what we need to do now in this particular problem is just define that interval. And I can tell you this, and I'm going to look at Evan when I say this, because the person that sits in his seat was the person that struggled with this the most last hour. The first thing you need to get through your head is that you are not, throughout the course of the day today, looking at those numbers. I can't encourage you to vandalize your Chromebook screens, so don't. But like if there was a way on your Chromebook to scribble out the y-axis, I can't stress to you enough, ignore the y-axis numbers. They don't mean anything today. We clear? So what we're studying is intervals, and you'll remember that intervals are defined by the numbers on the x-axis. So these are the numbers down here that we're going to use to answer this question. Could you guys describe for me the interval over which this function is going uphill? Where does it go? From where to where?
0 to 4.
From 0 to 4. But here's the thing. At 0, it's not technically increasing. FYI, it's sitting still at 0. So what's happening is anywhere between 0 and 4, it's increasing. But if you're sitting at 0, you're not increasing. Yeah. And if you're sitting at 4, why are we not increasing up here at 4?
Because you're at your peak.
Because you're at your peak. And like on a roller coaster, if you're going up a hill and then you go down a hill, there had to be a moment in time, infinitely small perhaps, where you were going neither uphill nor downhill. So we talk about this increasing interval. We say that it happens from 0 to 4. And note that I've chosen to use the round ones because what I want to say about this is that like the thing that I want to be true is not true at 0, and it's not true at 4. It's true over the interval between 0 and 4. So all I'm going to do now is go down to the bottom where I type in my answers, and I'm going to type in an interval. So I'm going to go down here, and I want the round. So you can see that's over here. And I'm going to choose from 0 to 4 and submit that. And oh, geez Louise. That's 3. God, you guys are just letting me go on and on. Yeah, but so you guys enjoyed that, don't you? That's always a real treat. That's a crowd pleaser. So that's one type of problem. How about this one? What's different about this graph than the last one? Like it's the same shapey kind of thing, but what's different this time? Ollie? So this time we have to talk about the concept of infinity, but you would agree again that since the problem asked us, I better check so I don't mess this up again. The problem asked for increasing. So you would agree that the increasing interval is this interval right here. And again, you look at my pen and it's going downhill. And a lot of people, they're like, well, how can you say that's increasing, you crackhead? It goes down. Because in math, we talk about math from left to right. And so even though the arrow points downhill, this interval exists in a left to right. We have to name it left to right. So how would you name my red interval? Mia, what would you call it?
I would call it.
First off, if you said the number 6, then you are doing exactly what I told you a minute ago not to do. Do not look at those numbers. I'm not going to do that every time.
-2.
How far left does my red interval go? Aiden? It goes to negative infinity. Very good. This graph, because there's an arrow on it, will keep going forever and ever and ever. Exactly what that arrow is saying is exactly what it'll keep doing. So this interval of this red part of my graph will go from negative infinity until when? What X value is it at when it reaches its apex?
1.
At 1. I'm going to look again this time and make sure that that's a 1. Is that a 1?
Yes.
Good. All right. Fingers crossed. So again, I know, right? So again, we're just going to go down here. We're going to pick the correct, there's all sorts of symbols and you'll learn what all these mean in time. But for now, I just want the round and I'm going to go negative. And you see there's a little infinity button here to +1. Oh, fingers crossed this time. Good.
Yeah.
Hooray.
Yeah.
Oh, snapdragons. Yes. God dang it. Go get Luke. Maybe.
The hallway.
Yeah, bring that Luke in here.
Oh my god.
That's just 1. Sorry, Luke.
Oh god.
Everybody-
Oh.
I may have to record again 7th hour because thankfully I didn't say a dirty word. Sorry, Luke.
Everybody.
My bad. We really do like you, Luke. I swear. We just forgot. We were so wrapped up in intervals that we forgot.
No. No.
Listen, as I click through some more of these, you're going to see the same thing again and again and again. So I'm not going to spend much time on this section, but you would agree that there are 2 intervals, right? There's a decreasing coming in from the left, and then there's an increasing leaving. And so how would you describe the increasing interval?
Infinity to
Nope.
negative. Sorry, negative infinity to
Nope. Increasing means it's going uphill. That is this interval.
Oh.
No, don't ignore those brains. Ignore
-1. Oh.
-1 to 3.
Good. So this interval goes from right here to forever this way, aka from -1 to positive infinity.
Yeah, that's what I was trying to say. And then
Left to right is the way intervals have to be defined. Okay. And again, I'm not going to be right there with you to scribble out the y-axis numbers. You have to listen to me and do that every time. Okay. You got to stop falling for that. They're not that math people aren't going to stop putting numbers on the y-axis for your convenience. You just need to know that in this context, I don't give a rip what they are. Literally 0 cares about those. We clear? We're not studying how high or how low the graph is right now. We're studying its behavior, and its behavior is described by what it's doing as we travel from left to right. So the y's mean nothing. So again, if I were to click through some more of these, which I honestly think I'm going to, we're just describing an interval. And this section, if I just gave you a whole assignment of this, you'd get bored pretty quick because they're all like, watch this. If I click new problem, look, it's another parabola. New problem. Oh my God, it's another parabola. Wait a second, discuss. Oh, it's another parabola. So like, yeah, man. What's up, Cody? Is this a decreasing? Okay, let me get to a decreasing. Honestly, it's the same thing, bro, but I'm sorry. Why are these all increasing? I got one. So if I had, I'm going to take my pen, I'm going to make my red pen a fatty and tell me if you agree. And you should always disagree with me if you feel like you need to. Like, it's not disrespectful to have differing opinions. Do you agree that that portion of the graph is going downhill?
Yes.
And I have just highlighted for you a decreasing interval. And again, we are going to ignore these numbers. right?
Rain.
And
Don't
we
even look at him.
we are simply
We don't
going
look at them.
we are simply going to study on the x-axis, where does that interval exist? Would you agree that the interval begins its existence right there, and that it ends its existence right there? Right? So we simply need to define this as an
Just
interval
say-
that runs from 5 to 13. Done.
Five.
Would 13 be a
Got it?
bracket? Because it's
No. And again, I get that you want to say square bracket because there's a solid circle there, but I want to go back to say something that I said before. At that point in time, it's actually not decreasing anymore. It's just stopped.
oh, okay.
So that's why. And honestly, I think delta would take it both ways. I remember this from last year. I think it'll take a square and it'll take a round in a case like that. But my take is it ought to be a round because it's really not changing anymore right there, is it? It's kind of a deep thing to say. Yes.
Well, I kind of get like the increasing and decreasing because
You
I
get it?
have physical science. So it like when I see a graph like that,
Yeah.
I'm like, oh, okay, it's just a velocity graph.
Perfect.
So thank you to Mr. Allen.
Yay, Mr. Allen.
Yeah,
This is where you might start to get confused, but not because it's hard.
Fun.
I know. Doesn't that look crazy hard? This is nuts.
You know what to do.
It's like a roller coaster.
So in this particular portion now, when delta gives you these problems, I need to introduce a new word to you now. What we've been talking about for the last 10 minutes is increasing and decreasing. And those aren't locations. Those are just behaviors, right? Increasing means you're going up. Decreasing means you're going down. No mention of where are you when you're doing that. Now we have two new words that describe where a graph is. If a graph is above the x-axis, we call it positive. Seems pretty common sense to me. If a graph is below the x-axis, we call it
negative.
negative. Again, seems pretty obvious to me. I feel like you should understand this. And if you don't, let me make this clear. This location right here is 0. Everything on that line has a y value of 0. Do you agree?
Yes.
Then logically, everything above it is positive and everything below it is negative, correct?
Mhm.
So having said that, we have to try to start describing graphs now, not just by what they're doing, but where they are. So we're going to get the double whammy on this. So first off, let's go identify this interval that they're asking me about in this problem. They're asking me about the interval that runs from negative infinity to a. And if you were up here with the red pen, you would agree that it's this interval right here, correct? So I want you to describe that interval for me. First off, is it increasing or decreasing?
Increasing or decreasing.
It is decreasing. And again, if you say increasing, it's because you're still falling for the stupid arrows. As we travel from left to right, you must agree that that graph is coming downhill.
Yeah, it's decreasing.
Left to right will save your bacon. So let's first off agree that the red part is decreasing.
Yes.
Is it positive or is it negative?
It's positive.
It's positive. Why? Where does it exist?
because it's up.
Above the x-axis. So I'm going to look for an option down here. You're about to see these are multiple choice questions. Have I knocked you to sleep over there? Sydney, are you okay? Oh. We're going to look for an option in the multiple choice that says positive and decreasing. So I'm going to scroll down to the bottom now and we're going to look for positive and decreasing. And I see positive right there and decreasing right there. So on these problems, you get to pick multiple choice ones that match. Let's try another one. A new problem. No, that's the same stupid one. Let's get a better one. Okay, this is good. From C to D. So I'm going to highlight it for you. It runs right here to right here. Could you guys use 2 words to describe that interval for me?
It's
Cody, what you got? It's negative because it's below and it's decreasing because it goes downhill. So I'm simply going to look for negative and decreasing, and there it is. It's negative and it's decreasing. Okay, let's try another one.
you know that only one.
B to C. How would you guys describe this purple interval right here from B to C?
Decreasing.
Evan, what would you say it is? Evan?
Positive and decreasing.
I couldn't agree with you more, Evan. It's positive because it's above the x-axis and it's decreasing because it's going downhill. Okay, good job, Evan. Let's do another one. I think you guys are going to nail this section. No troubles here. How about the interval from B to C? That's this one. Positive decreasing. Let's go again. The interval from D to E.
That's
Positive decreasing. Let's go again. Interval from E to F.
Negative.
Negative decreasing. Negative decreasing. Next one from E to F this time.
Negative.
Positive increasing because it's going uphill. So let's get to the last section. This is the one that I failed my last class. I'm not going to fail you guys. We're going to spend a few minutes here, okay? So
Okay.
if you're starting to fade, get back up because this is the part that was. I know this is the part that I can't believe I left this out. So,
good. Like you were trying to draw a straight line on a bus. And just,
don't worry about how funny the graphs look. What we're going to talk about is the language of this today. So yeah, I got through the lesson and basically imagine if I stopped the lesson right there and then said, okay, let's get out our computers and I let you go to Delta Math and the first thing you see is this. You'd feel like, oh, okay, I just got ripped off. So what this is trying to ask us to do now is find the values or the intervals on which
F of X.
this is true. And the first thing we as a class need to do, and this is a team effort, like you have to speak up if this doesn't make sense. We have to come to an agreement on the following question. What in the world does that even mean? The first thing you need to agree on is this, and not because you've maybe known this before, but I'm going to tell you that from this point on in your math life, when you see f of x, you should think of it as y. A function value and f of x value is essentially a y coordinate value. So what this is asking us to do is find all intervals on this graph for which y is less than or equal to 0. Now that means, remember, that I can either be at 0, like on that line called the x-axis, or I can be where, above it or below it?
Below it.
Below it, because it clearly says less than or equal to 0. So I'm going to take my pen now and I'm going to highlight the parts of this graph that I believe meet this criteria.
Mhm.
Did I miss any?
No.
Would you agree that all the rest of that funky graph that does its thing does not meet the criterion because it is not on or below the x-axis, correct?
Right.
So what I need to do now is define this interval that I've just turned red. Now, I'm going to do something that is wrong. I'm going to mess up for the second time today, but this time it's on purpose. Why is that incorrect? Odie, you want to take a shot? Nope, intervals are still x-axis. And actually, here, if this helps, even on problems like this,
Let me look at that.
yeah, Katie? Nope, because we're going to the right. There is a mistake. Ollie?
Bracket 3 should be squared.
Why in the world?
It's at 3 1 0.
Good. The key to this, good job there, Oliver. The key to this problem is understanding that this statement right here carries a lot of meaning. Does it say that the graph has to be less than 0? Nope. It says that the graph has to be less than or is also allowed to be equal to 0. And at this point, I'm going to make it green right here. I need you to agree with me that at that point, it equals 0, right?
Yeah.
And Ollie nailed it. So exactly correct that this round bracket on the left in this case actually has to be a square bracket because at the x value of 3, the criterion is being met. The graph is below or on the x-axis. Yes, sir? Got it? Let's do another one of these. Yes, Ollie, what's up? I'm gonna show you that because that's gonna be probably what happens next. You mean more than one interval, I assume? Yeah, I'll show you. And then I don't know where you guys are at with your learning right now, but here's a good one. Okay, pop quiz. Not really, just a question. I like to say that. This is asking me for the intervals on which the graph is decreasing. How many decreasing intervals do you guys see?
There's one, there's two,
Three.
there's three, there's four.
I see 3.
I see four.
I see 3. And now let's argue about it after I draw the ones that I think. And if you think I missed one, you should tell me. I love that kind of stuff. So here it goes. I'm going to draw a decreasing interval
That's one.
because that is going downhill, correct? And I'll put a little arrow on there to make it official. And I'm pretty sure that this is a decreasing interval from here to here. Do you agree?
Yep.
And I'm pretty sure that this is a decreasing interval because it goes downhill. And I would challenge you at this point to show me which one I missed.
Maybe
Are there
I
any
missed
more
one.
intervals that go downhill?
Oh, wait. Yes, there is.
I'm
So,
pretty sure.
Before that line that you did
I th-
over that slope thing.
I think this
Yeah,
is
that.
that's increasing. It goes uphill. And this is increasing. It goes uphill.
Hmm.
The red intervals go downhill.
Hmm.
So this goes
Maybe
back to
I-
all these questions of how do I do it when there's more than one answer? Well, I'm going to show you right now. And then I know that like poor up here in the front, I don't want to use your name because I'm recording right now, but you look like you're just ready to go. Like, are you falling asleep? You can stay with me for a couple more minutes. You gonna make it?
Not kidding.
Good. I know from your last quiz that you generally do get it. I'm impressed. Could someone please describe for me or give me the name of the interval that I'm pointing at with an arrow? I'm ready. From negative infinity to -4. Thank you. 1 down, 2 to go. Could someone please describe for me? Bless you. This interval, someone not Ollie, because you did the last one. Cody, go ahead. From -2 to +2. And finally, someone new. I want the name of that interval over there.
Isn't it like nine?
It is from 5 to
Infinity.
good. Now what I'm going to do is I'm going to erase a whole bunch of this and I'm going to show you how we type this into Delta.
Okay.
And so, bless you. So I'm going to go down here to the answer box. Now the first interval is from, and I want round on these. Remember with increase, decrease, we're never going to have square brackets. Okay. Always round because at the ends of those intervals, you're not increasing or decreasing. So I want to round and I want negative infinity. So negative infinity sign and it stopped. Remember, I wrote it down at -4. Now, if you guys want another interval, here's what you do. You see this little plus button over here?
Yes.
Just click it. Whoop, and now you get another answer box. So let's put the second interval in. He is also round from -2 to +2. Whoop, and then look. Boop, get another answer. And this one goes from round, 5 to infinity. So 5 to infinity. And Ollie, that is how you do it when there's more than one interval. Yes,
Go back into the graph for a second.
sure.
Double check.
Where did -2 come from?
Okay, yeah, it is negative. The way you drew it, very much. more-
Oh, I see, okay. from the-
Right here
Yes, I see. I
to right here. Yep. How you feel? Other than the fact that I've just destroyed you with a long, boring lecture, do you kind of understand what's going on? Positive means it's above the x-axis. Negative means below. It doesn't mean anything about if it's going uphill or downhill. It's where it is. Increasing means uphill. Decreasing means downhill. So I'm going to give you 9 minutes here. I'm a little scared. Bust out your Chromebooks, hop in there and start trying some problems off of Delta Math number 11. Let's see how this goes. Let's take it for a spin. Yes.
I needed to wait because you were doing a little, but can I use something?
Resume. So for yours, the first thing I'm going to do is I'm going to go through and I'm going to highlight all the things that make this statement true. And so I'm going to highlight with my red from here to here. And then I'm going to highlight all the way from here to here to here to here. And what is true about everything that I've drawn in red? Katie, what's true about everything that's red? Say again. Right. And that's basically what this is saying up here is just, I need you to be below. Like these questions are just asking us, when is the graph above and when is the graph below? Less than or equal to means below. But the thing is, like this stretch, this purple stretch from here to here can be done in just one interval, because normally this point, I'm going to point to it with a green arrow. Normally this point would cause me great concern because it's not increasing and it's not decreasing. But because the problem says that it can be equal to 0, then that point can just stay and flow as part of your interval. So you're going to have 2 intervals, dude. So your first interval is going to run from, thank you for fixing that, by the way. Your first interval is going to run from, so this interval can be described as -infinity to -8. And I'm going to put a square bracket on this side because at this big red point right here, we agree that it is equal to 0, and that's allowed. So that's why it gets a square bracket. Could you describe for me the big long purple interval for me? It's going to go from -4 to what? Right here. Nice job, Katie. So you just have to put in those 2 intervals and you are done. You're just trying to define or determine or describe the intervals over which what they want to be true is true. So that's that. Ollie, what's up, bud? I can. Katie, you got this? Oh, square bracket on that -8, Katie.
Both -8.
Do you see the one on there? You go. Ollie, I'll pull up your screen here as soon as Katie gets this typed in, okay? I can't see the question, Cody. I don't know what you got to scroll up, bro. I don't know what the question is. Okay, so we want below. So you should have -8 to or +2, and then 6 to infinity. Yep. Good. Yep. Let's go.
I haven't touched it at all since I have answered it and it says wrong.